Alright, so we've got a good probability question here. Greg and Jack are playing in a golf tournament. They'll play 2 rounds and each has an equal chance of winning the first round. If Greg wins the first round, his probability of winning the second is 0.6. If Greg loses the first round, his probability of winning the second round is reduced to 0.3. Okay, so we know that they're playing 2 rounds of golf. And we're asked to draw a tree diagram for starters. So I would straight away, even if you weren't asked to draw this, it's a 2-stepper. Okay, so the options are, if we just look at it as the first round, this is round 1, this is round 2. Now the first round can be won by either Jack or Greg. Okay, now you could possibly set this up as a win-loss kind of thing, but realistically, ultimately we're going to have 4 scenarios here. We're going to have Jack wins both, or we've got Jack wins 1 and Greg wins this. Jack wins the first, Greg wins the second. Greg wins the first, Jack wins the second, and then Greg wins both. Okay, those are our 4 possible outcomes. And if we go and look at the probabilities here, well, each has an equal chance of winning the first round. Right? Well, the first round there's 0.5. They're equally likely. Now they're saying here that if Greg wins the first round, so we're down here, his probability of winning the second round is increased to 0.6. So if he wins the first round, he's got the confidence, goes up to 0.6. Well, of course, Jack then has a 0.4% chance. Because again, these two numbers here have to add up to 1. No other option but to add up to 1, because if they don't, we're not including everything in our sample space. And if we look at our second option here, if Greg loses the first round, that's here, so Jack winning the first round, then we're going to have Greg having a 0.3% chance of winning. And again, that's got to be a 0.7 chance of winning. Everything on each of the 2 branches here, and these two as well for that matter, have to add up to 1. Each of the outcomes at each stage has to add up to 1. So that's our tree diagram. Okay, so I would think this would probably be worth 2 marks each. Older exams, so they don't label it that way, but I would think that they're worth 2 marks each. Okay, so looking at that's our part 1. Part 2, well, find the probability that Greg wins exactly 1 round. Okay, well, where does Greg win 1 round? We've got 4 options. He doesn't win 1 round there. He has 2 losses. He also doesn't win 1 round there because he's won both. So we're looking at these 2. So the probability of 1 win is, what we can have is either Jack then Greg or Greg then Jack. Now obviously if I go Jack then Greg, I'm following this path. I go up to there and then down here, so it's 0.5 times 0.3. So it'll be 0.5 by 0.3 plus, well obviously I've got another path there as well. I can go down here, and then Greg wins the first and Jack wins the second, so I'm looking at that one there. And that one is just 0.5 plus 0.4. So what's that? 0.15 plus 0.2 is 0.35. Now we could write that as a fraction, 7 over 20, or 35%. Not sure how the answer is given, but any one of those is fine. Personally, I would just forget about those altogether and just go with the decimal that you're given there. Okay, so again, if we've got a 2-round sequence, a two-step process, we're drawing some sort of tree. Here you're asked to, all well and good. You get marks for what you would have done anyway, but if you were not asked to draw a tree, still drawing a tree diagram. And it's not a win-loss scenario because we're not talking about one person. If we're talking about one person playing 2 rounds of golf, we'd go, okay, well he can win, or he can lose, and he can win, then he can lose, and so on. Well, we could set it up that way, but I think it's easier to actually set up this way because we've got another person involved as well. And I think that tree diagram is quite self-explanatory as well. I hope that helps, and I'm quite certain that'll be the same answer that the HSC paper's got.